we move on to the fourth technique, that is traffic throttling. So what is happening here? So in the network and many other computer networks, the senders adjust their transmission to send as many traffic as the network can directly deliver. So this is the typical scenario that we already seen. So when before sending, the sender will adjust their transmission to a level that the network can handle, right? So by admission control and traffic aware routing and other technique, this is what we seen already. So in this setting, the network aims to operate just before the onset of congestion. So before congestion, so far everything is fine, so we are trying to avoid. So all these are the preventive mechanisms, and they are taking slower in pace, right? So when the congestion is imminent, so once it happened and there is no other way for us to escape from it, it must tell the senders to throttle back their transmission and slow down. So there should be some way of communicating the sender, because congestion already happened beyond our control. Even though we taken care, like we tried to adjust our traffic, everything, maybe by the traffic shaping technique and admission control, everything we tried to send traffic in such a way that this is what the network can handle. But due to some reason, if things gone out of our control, then we are supposed to throttle back their transmission, and we have to tell the senders to withdraw traffic and or slow down somehow, right? So the approaches to throttling traffic must solve two problems. So how we can control traffic at the sender level, right? The sender is assuming that things were going fine, but later point some congestion already happened without even after taking all the precautions. And that time somehow you should force a sender to slow down traffic. So that is the idea. And there were two things or two problems we have to consider at this point. The first one is the routers must determine when congestion is approaching, ideally before it has arrived, right? So before the arrival of the congestion, the routers are supposed to determine the point at which that feedback is to be communicated. So this is the first thing. So when the congestion is approaching, so there should be some guessing for that. So once it know that, so now the congestion happened just now, or it is going to happen, and that time it can communicate back the sender regarding its slow down the speed of communication, or maybe reducing the data by 50%. In any way it can give some kind of feedback. So that is the second thing, how the feedback is to be given back to the sender. First problem we are facing is regarding how to determine when the congestion is approaching. So the solutions we will see. So to do so, each router can continuously monitor the resources it is using. So by looking at the resources and their utilization, we can understand whether it is going smooth or the congestion, whether it is going to happen or not, right? So there are three possibilities are the utilization. Like in three ways you can monitor. The first thing, you can monitor the utilization of the outgoing link, like so by looking at so this many outgoing links, so how what percentage of the outgoing links and what percentage of time they were utilized, that you can monitor. That is one way. Another way, so the buffering of the queued packets inside the router. So what about the queue length, the average queue length? So that is an indication of the resource requirement and whether it is going to happen congestion or not. And the third thing is the number of packets that are lost due to insufficient buffering. So that means the point at which the congestion started. So that is why the packets started lost at the router, or the router started discarding them, and how many are lost, that also you can count. Even though three measures were there, the second one is useful, that is about the average queue length is something that you can depend all the time, because if you look at the first thing, that is the utilization of the outgoing link, the average utilization do not directly amount the burstness of the most traffic. So it is not a direct measure of the congestion, in the sense it is not going to give a direct measure of the burstness of the traffic. So it is something like that depends on the type of traffic, the utilization, and its meaning will vary. For example, a utilization of 50% may be a very low utilization if you look at smooth traffic, particularly that streamlined traffic and all. But for a variable bursty traffic, this 50% itself is a high value, right? So depending on the type of whether it is streamlined or bursty or smooth or variable, the utilization and its interpretation will vary. So that is not going to be a good measure. Now when the third thing, that is the count the number of packet losses, right? So that is somewhat we are too late, in the sense the congestion has already set in by the time that the packets are lost, right? So all the packet loss means the congestion already started, so we are too late to have a observation of the network. So it should happen somewhat early, right? So the best way to do this is by depending on the queue length. So that can be taken as a measure of the current congestion scenario. So how that queue delay is contributing. The queuing delay inside the router directly captures any congestion experienced by the packets there. So it should be low most of the time. If you look at the queuing delay, that will be less because everything is working fine, but it will jump suddenly when there is a burst of traffic that generates a backlog, of course. So to maintain a good estimate of the queuing delay, say D, a sample of the instantaneous queue length, the instantaneous, so at any time take the instantaneous queue length, say S, that can be made periodically. So you can do this calculation of the instantaneous queue length in a periodic way, and in at the interval you can update that D, that is queuing delay, according to a formulation, that is the D nu is equal to alpha D old plus 1 minus alpha into S. So like that you can update. So this is the formulation we are using. Okay, right? So what are all the values? So here you are using something called alpha. We will see what it is. So to get the new value of the queuing delay D, you are depending on the old value, also the current queue length, right? So it's something where this alpha determines how fast the router forgets the recent history. For example, if you are choosing this alpha to be 1, it is something like the new every time the new queuing delay is nothing but the old one. So you are just depending it more, right? So but if you are taking alpha to be 0, you are simply forgetting the recent history and you are purely focusing your queuing delay as a direct function of the average queue length. But that is also not good, because right now the queue length may be suddenly increased to some due to some bursty traffic, but just some time before that it will be some other value. So it is always better to choose a value between 0 and say 0.5, something like that, so that you can consider both into consideration. So what could be the value? That could be maybe based on some estimate, and we can set a value of this alpha between 0 and 1. So this is sometimes called the exponentially weighted moving average. So this is generally you may see in this kind of alpha tuning in other context also. So in general, so they are actually giving some kind of weighted average. So they are helping to calculate some weighted average for the queuing delay. So or they smooth out the fluctuations, and it is somewhat equivalent to the low pass filter, right? So in that way you can imagine that alpha. So whenever D moves above the threshold, so now once you every time you are updating your queuing delay D using that formulation, now after updating you cross check with some threshold value, and if it is moving above the threshold, you can see that yeah, congestion is it is on onset of congestion, right? Like that you can conclude. So that is how we are determining the congestion scenario. So once you understood that the congestion just happened or it is just going to happen, and that time the next thing is you are supposed to inform some kind of the senders about it by providing some kind of feedback. The second problem is that the routers must deliver timely feedback. So the feedback, simple feedback is not enough. It has to be done in a timely manner to the sender that are causing congestion. So who is responsible for it? try to inform them. So congestion is experienced in the network, but relieving congestion requires action on behalf of the sender. So even though the congestion is happening in the network, it is the sender who has to control the situation from being going into some worst case, right? So senders are supposed to slow down, otherwise it will not be in control. So congestion requires action on behalf of the senders that are using the network for the relieving purpose. So how the senders can be given feedback? To deliver feedback, the router must identify the appropriate senders. That actually some of the senders will be dominating the entire traffic. So if they are reducing, that will be good, right? So appropriate senders has to be identified. So we will see how that will happen. It must then warn them carefully without sending many more packets into the already congested network. So it's already congested, so don't send more number of packets. So like that we should be able to control the sender. So different schemes are in use at different feedback mechanism, like chalk packet is one technique for the feedback mechanism, and explicit congestion notification, that is ECN, and another approach is hop by hop back pressure. And these three technique is we will see in detail. It's a very simple technique only, maybe in the next video, right? So otherwise the video length will be more, so that is why I thought of stopping at this point, and those three technique we will feedback technique we will continue in the next